We are going to look at a presentation which is part of migrating a campus network from flat to routed, and it's part of the campus network design and operations workshop. For this section, we are going to look at DHCP and how it plays a role in migrating a campus network from flat design to a routed design. This diagram shows the ideal routed campus network. You have your border router at the top, you have your core router, and you have a subnet for the link between them, and then you have a subnet for each building. We have one example, and you have your servers centrally located, connected to your core router. Remember, this is so that you can provide redundancy in terms of power and in terms of connectivity to the servers, as well as the fastest possible connection to everybody across your campus. In this example, we've picked different /24s for the links to the different buildings, and out of the 10/8 network. So when you're changing from a flat network, it implies that nearly everything needs to be renumbered. The truth is you can keep just one subnet, because the current subnet that you're using, you can end up moving everybody else off of it except either one building or one part of the network. So you could figure out which is the hardest to renumber. And typically this might be the servers, depending on how your services are run and where the IP addresses are hard-coded. So the first step before you start migrating is to try and get as much as possible onto DHCP. This will let you do the renumbering centrally. So let's look at a quick refresher about how DHCP works. It's standardized in RFC 2131. A DHCP exchange is 4 UDP messages. The first one is the client sends a discover broadcast, UDP broadcast. One or more servers replies with an offer, which could be broadcast or unicast. Usually it's unicast. Then the client picks one offer and then sends a request, and then to the server that sent, it sends a unicast request to the server that gave that offer, and the server will respond with an acknowledgement to confirm the reservation of that address. Each address is granted for a finite lease time. So when the lease time is nearly over, the client must send another request packet, and then the server will confirm with an ACK the reservation, but it will also extend the expiry of the lease time. So it's a good idea to reduce the lease time in advance of renumbering. So for example, let's say on your network, your current lease time is 24 hours. You want to reduce this down to 10 minutes, but you have to wait for 24 hours before you start making changes. After 24 hours, you can be sure that every device is refreshing its address every 10 minutes. So it minimizes the time for new addresses to be picked up. Then when you're done, you can put it back up after the change has been tested and it's successful. If you have very long lease times, like a week, it means you should plan your changes like a week in advance and turn the lease times down, wait for a week, and then start doing your changes. So it requires some planning. Now, in addition to the address, the DHCP response can contain other settings to configure the client: the net mask, the default gateway, DNS servers, the default domain, SIP server for IP phones, the TFTP boot server for diskless clients, the controller for access points. So this centralizes all client network configuration in one place so that you don't have to go on device per device. Additionally, when you're managing devices, we recommend highly that you use DHCP to configure the devices that would have static IP addresses. For example, printers, phones, administration workstations, even your access points. So what you do is the DHCP server can be configured with a mapping of the MAC address to a fixed IP address. and that way it will always hand out that IP address to the device. In some cases, you might want to replace the device. So for example, a network printer dies and you install a new one. You just change the MAC address inside the DHCP server, and the new printer will have the same IP address as the old printer. DHCP logs will be a useful source of address pool availability so that you can keep a watch on how big your pool is and how many addresses are being held. It depends on how many devices are there plus how long your lease times are.